Lesson 7-8, Graphs of Polar Equations. To graph a polar equation, you make a table. This table is unique in that you pick the second variable, you pick theta, and calculate r. Because our equations are usually set up to be r equals something with theta. So I put this in my calculator. You can change the calculator to polar mode. And then when you put it in, you can go to your table settings and you can have your step size. You can put in like pi over 12 because that is the typical spacing of the lines. And this is the table my calculator gave me. So then plot all the points. And draw the curve. So hey, that makes a circle. Polar equations can have symmetry. So here are the tests for symmetry. So what you do is you make the replacement that's suggested and simplify to see if you get the original equation. If you get the original equation, then it has that symmetry. So see if it's symmetric about the line theta equals pi over 2, which is like x equals 0, or the y-axis if we're in rectangular coordinates. You replace the r theta with r pi minus theta or negative r negative theta. Now, sometimes one of these replacements works and the other one does not. If one of the replacements works, then it does have that symmetry, so you might have to test both replacements. For the polar axis, this would be like y equals 0, or the x-axis, place r theta with r negative theta, or negative r pi minus theta. And again, you might have to try both of them, see if you can find one that works. Or the pole, otherwise known as origin symmetry, that's the 180-degree rotational symmetry. Replace r theta with r pi plus theta, or negative r theta. And again, you may have to try both. So you may potentially have to be trying 6 different substitutions, so surely there's a shortcut. If the function is a function of cosine, and just cosine, then it's probably polar axis symmetry. If it's a function of sine, then it's theta equals pi over 2 symmetry. Otherwise, you'll have to try the replacements. Let's find the symmetry of the equation theta equals pi over 4. Now, just so you get an idea, if I graph it, pi over 4 is there, so it's a diagonal line. But let's go ahead and test all our symmetries. Let's test the symmetry theta equals pi over 2, or the y-axis symmetry, and it's not going to have that, but let's go ahead and show why. So we could replace r theta with r negative theta. So the theta becomes negative theta. So I replace theta with negative theta, and I simplify, and that's negative pi over 4. That is not the same. So then we can try the polar axis. Replace theta with negative theta, so we'd have it's theta equals pi over 4, so negative theta equals pi over 4, which gives me negative pi over 4, which is not the same, so it's not polar axis. So let's try a pole. Replace theta with a theta, so you get, obviously if I don't change anything, it'll stay the same. So it's the same, so it has polar symmetry, meaning if I rotate this 180 degrees, it'll look the same, which it does. All right, let's find the symmetry of r equals 2, 1 minus sine theta. Wow, this one could be fun. This one could take a while. What's it even look like? Well, we could use a quick test. It is sine. Sine, the quick test says it is the line because it's sine, that's the symmetry. Don't you like shortcuts? Polar equations also have minimum, maximums, and zeros. The maximums occur when the radius is the largest. And so we're talking both furthest from 0, so its absolute value of r is largest. So for that, you find the angles where the trigonometric function would be at its maximum. The zeros occur when the radius is 0, so you'd find places where the trig function is 0. Let's find the zeros and maximum values of this function. To find the zeros, you let r be 0, and then you divide by 5. So since it's 5 times cosine, we'll only get a 0 when the cosine of 2 theta is 0. So we need to find out where on the unit circle is cosine equal to 0. Well, cosine is x, so the x is 0 there and there. So my angle, 2 theta, is pi over 2, or 3 pi over 2. But it's 2 theta, which means we're going to divide by 2, which means I need to go around the circle twice. So it would come back to the top, which is 3 pi over 2, and then 7 pi over 2. And then we'll divide by 2 to get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So those are the zeros. For the maximums, we want this to be the maximum value. So this is going to occur when the cosine is the maximum. So what is the maximum value of cosine? That's when it's 1 or negative 1. So we want to know when this is 1 or negative 1. Well, cosine is x, so the x is at 1 there, negative 1 there. So our angle is 2 theta, and it's 1 at 0, and it is negative 1 at pi. But we're going to divide by 2, so let's go around the circle one more time. So it'll also be 2 pi and 3 pi. And then divide everything by 2. You'll 0 pi over 2, pi, and 3 pi over 2. Let's graph it and see how that looks. So I'm going to go to Grapher on my Gnomworks calculator. I'm going to add an element. I want to add a polar. And it was 5 cosine of 2 theta. Let's look at the graph. Notice we're at maximums at 0, pi over 2, pi, and 3 pi over 2. And it goes through 0 halfway in between. Makes a nice little flower.